This flight will be from the Long Beach airport where we left off, about 100 miles northwest to Santa Maria, and it's a great, stable IFR morning for IFR practice. Ceilings are in the marginal VFR to IFR range, and as low as 500 feet at our destination airport of Santa Maria. We're planning an RNAV SID at Long Beach, and then the localizer backcourse alpha approach at Santa Maria, where the weather's low enough that we probably won't get in on that approach, so we'll plan on doing the ILS 1-2 after that. The first thing we'll need to deal with, though, is ground operations at Long Beach, which is a busy, complicated airport. We can see these orange circles scattered throughout the airport diagram. These are the hotspots, and next to each circle is a hotspot number, so hotspot 1, hotspot 2, hotspot 3, and so on. Hotspots exist where runway incursions have occurred or are expected to be more likely to occur. And we can find more information for these if we go to InForFlight on the Airports tab, and then Procedures, and Airport, and then Hotspot. This is a document with all the airports that have hotspots listed, along with a description that's either just the location of the hotspot, or in some cases the reason for the hotspot. Zooming in at Long Beach, then, we can see that hotspot number 1 is just the intersection of runway 1230 and 8 left, 26 right, and taxiway Bravo and taxiway Kilo, so just a complicated intersection there. Hotspot 4 gives a little insight into why there's a hotspot there. Runway 12 and 30 crosses every other runway on the airport. And there's a lot of runways at Long Beach. In fact, there used to be 2 more. There used to be 2 north-south parallel runways here also. When we get in the plane and brief our taxi route, we'll look at another way that we can get information about these hotspots using the GTN 750. We'll be filing for the Hawk 3 SID and the IK transition, which is a combination vectored and pilot nav SID. Specifically, it'll be runway heading to a certain altitude, followed by a turn to another heading, the specifics depending on which runway we use. And then we'll be getting vectors to join the departure at Pigeon, most likely. And you really want to make sure that you read the text on these. Don't assume that you understand what's being said by the diagram. Sometimes there's some ambiguities, sometimes there's things that aren't completely clear from the diagram. Similarly, don't assume that your GPS is going to sequence the departure properly for you. For example, on this one, the GPS can't know what vectors you've been given and when you've been cleared direct to Pigeon or to some other point on the SID. So you have to look at what's in the GPS flight plan and understand when you need to manually sequence things. But understand the procedure and make sure that if you're using automation to fly it, that it's doing it properly. On SIDs, you should be aware of any takeoff minimums or any notes that might restrict who can fly the SID. Here it's not a problem. We have takeoff minimums off of 8 left and right and 1, 2, and 30, which are standard. So that implies just a 200 foot per nautical mile climb is required. And the steepest one would be off of 26 left, which is standard with a minimum climb of 330 feet per nautical mile to just 700 feet. So no problem in the Barren. None of the notes are a problem for us either. Radar required, RNAV1 capability we have GPS, and we're not a turbojet aircraft, so we're good to go on this procedure. Pilots who don't often fly SIDs sometimes mistake which altitudes they're meant to fly and mistake the meaning of different instructions they get as they fly the SID. So let's see if we can clarify some of these issues a little bit. So first, let's separate the lateral part of the SID from the vertical. If you're cleared via the Hawk 3 departure IK transition, that refers only to the lateral part of the SID. That clearance, though, says nothing about what altitudes to fly. So if ATC gives you that clearance for the SID and then climb and maintain 8,000, that's exactly what you'd do. You'd climb directly to 8,000 and ignore all the charted altitudes. If ATC does want you to fly the charted altitudes, they'll say climb via the Hawk 3 departure or climb via the SID. Climb via means you should climb to the published top altitude and meet any altitude restrictions along the way. And these are the altitudes beside waypoints with lines above, below, or both. A line above indicates a ceiling that you have to cross at or below. A line below is a floor, and you need to cross it at or above. And lines above and below indicate both a ceiling and a floor, or in other words, you should cross at exactly that altitude. So here, given an instruction to climb via the SID, we'd cross Pigeon at or above 4,000, Hawk at or above 5,000, and Robin at exactly 6,000, and then we'd remain at 6,000 because that's the published top altitude. It's worth pointing out that Pigeon, Hawk, Robin, and Oriole are all birds, but Moose is not. That's not significant, but I feel like it is noteworthy. Anyway, there are a few ways ATC might alter the climb profile. If they wanted to amend the top altitude, that would sound like climb via the SID, except maintain 8,000. That except maintain phraseology can be problematic because it's not intuitively clear that it means to amend the top altitude. So when you hear except maintain, translate it to except amend the top altitude too. So you'd follow all the restrictions at Pigeon, Hawk, and Robin, but then you'd continue climbing to 8,000 instead of 6,000. Some SIDs indicate that ATC will assign the top altitude, and in that case, they'll do that using the same except maintain phraseology. Other amendments you might get are more straightforward. Climb via the SID except cross Hawk at 5,000 would mean exactly that. Instead of crossing Hawk at or above 5,000, you now must cross at exactly 5,000. Any climb instruction you receive at any point overrides any previous climb instructions. If you were told to climb via the SID, but then later ATC says climb and maintain 8,000, the climb via clearance is gone, and so are the restrictions on the SID, and now you should simply climb directly to 8,000. There is some confusion on this point sometimes, and pilots often ask ATC whether the restrictions still apply, and as a result, you'll sometimes hear ATC preempt that question by saying climb unrestricted, maintain 8,000. It's not necessary to say that, and it perpetuates the misunderstanding, but it's a symptom of an unintuitive system, and it's not really ATC's fault. The altitudes above each segment are not meant to be flown. These function more like MEAs, and they provide at least IFR obstacle clearance and navigation coverage, but they're primarily used for planning and situational awareness, and you shouldn't generally find yourself below them. They're not part of a climb via clearance, though. Many pilots of light GA aircraft get rusty on SID procedures because they just don't fly them very often. If there's any doubt, you should ask ATC, but it's pretty important to get it right here. The climb restrictions here are what keep you separated from multiple traffic flows in and out of the LAX area. At Santa Maria, we're going to be requesting the localizer back course alpha approach, which is not a type of approach that you fly very often, but when you do find yourself flying one, there's some quirks that you want to keep in mind. The thing that's traditionally difficult with back course approaches is what's called reverse sensing. And sensing isn't actually different in this case, it's just that we're flying backwards on the localizer, so right becomes left and left becomes right. And that's tougher than it might sound to fly because you're fighting some instincts that you've spent a long time building up. With an HSI, what we can do is set the ILS front course direction, which effectively just turns the needle upside down and reverses its directions, and now we just fly it normally. The downside to this is there's a little more work to do when we transition segments. Sometimes we'll find ourselves rotating the OBS by 180 degrees at busy times. If we don't have an HSI, we're stuck with those backwards deflections, but I would still set the front course in that case because it at least makes the needle deflect towards the correct cardinal directions. So for example, on this approach, if we find ourselves southwest of the localizer, the needle will be deflected to the left, which is opposite what we would expect normally. But at least in this case, the needle's deflected towards northeast, which is the direction we need to fly to get back on the localizer. It's also just a reminder of the reverse sensing issue. If we look at the OBS setting and it's opposite the direction that we're flying, that'll be a reminder that something's different and that the corrections that we need to make would be opposite the direction that they normally are. If you have an autopilot, it can probably track a back course in either back course or reverse mode. But you definitely want to read the manual because there's usually some specifics that you need to get right in order to have the autopilot track the course correctly. Usually the front course needs to be set. We have a really nice GPS in the panel, so we should be able to use that to make our job easier when we fly a back course approach. The AIM allows you to use your GPS to substitute for VOR, ADF, and DME, with the exception of whatever's providing the lateral guidance on the final approach segment. For a long time, there was kind of a gray area here where pilots would fly a VOR approach, for example, using GPS because it's easier and it's simpler, and just display the VOR on another radio, so on the nav2, for example. That was originally sort of a gray area, but a change to the AIM made that explicitly okay. Now the VOR or ADF doesn't need to be the primary nav source, but it still must be displayed and monitored. The best way to fly a VOR approach then with our equipment is to essentially fly it with the GPS, but set up the nav2 to the VOR and the inbound course. So the gray area in the AIM is gone with regards to VOR and NDB approaches, but not so much with localizer approaches. With localizer-based courses, the localizer is still the primary guidance, but because it's quite a bit simpler to keep the GPS driving nav1 on an approach like this, I'm going to do it that way and set the localizer back course on the nav2. But the nav2 then is truly my primary guidance. So if there's any discrepancy, nav2 wins out. Or more likely, if there's any discrepancy, we go do something else, because there shouldn't be a discrepancy if everything's working and everything's set up correctly. I wouldn't do the same thing for a localizer approach. I certainly wouldn't do the same thing for an ILS approach with a glide slope. But localizer back courses are just kind of uniquely quirky, and I think it's quite a bit easier to fly it the way I just described. By the way, another thing that makes localizer back course approaches tricky to fly is that the localizer transmitter is now at the near end of the runway. So we end up flying directly over it, at which point it gets really sensitive to the point of being pretty useless as we fly over it. And so that's why usually you'll find the missed approach point on a back course approach quite a bit before the end of the runway. Like here, it's a full 0.7 miles before the threshold. Another thing that's noteworthy about this approach is that it's perfectly lined up with runway 30, but there's no straight-in minimums. It's just a circling-only approach. There's several possible reasons that an approach would not have any straight-in minimums, but the bottom line is that they all point to the potential difficulty of making a straight-in landing using normal maneuvers. There's some less common reasons for this, like insufficient runway markings or an approach that doesn't intersect the extended centerline close enough. But easily the most common reasons are, number one, that the approach is not aligned within 30 degrees or 15 degrees for RNAV approaches with the runway. And that's not the case here. It's perfectly aligned with runway 30. A second reason is that the descent angle might be too steep, and the number that's used here is 400 feet per nautical mile. If the gradient's steeper than 400 feet per nautical mile, there won't be any straight-in minimums published. And that's what the issue is here. So here it's the descent from Pater to the runway, where we need to lose about 1,500 feet in just under 2.5 miles, which comes out to around 600 feet per mile, or if we're doing 120 knots, 2 miles per minute, 1,200 feet per minute is what's required. And that's the best case scenario where we see the runway by the time we get to Pater and we can start the descent right at Pater. If the visibility is anything close to minimums, we won't see the runway until even after that, and it would be an even steeper descent. So we shouldn't even try to make a straight-in landing on runway 30. Instead, what we'll do is if runway 30 is in use, we'll plan on entering the upwind and then circling back to land on runway 30. ATC might assign initially just a straight-in landing on runway 30, but that doesn't mean that we can do it. We should know that that's not something we want to do and decline that and request the upwind and a circle back to runway 30. So what if prior to reaching Pater we have the runway in sight? Can we then descend below the step-down altitude at Pater? The answer to that is actually no. Pater is still a mandatory at or above altitude, and it's mandatory at or above for good reason. Zooming in on the chart, you can clearly see the terrain that's causing that step-down to be so high. It's visible on the chart, but it wouldn't be visible at night or potentially in low visibility. So you might have the runway in sight and start descending for it, but if you get below that minimum altitude, that terrain could be in play. What if the PAPI is in view and it's showing you on glide path? You still don't want to descend below the minimum altitude. There's no protection below 1720 at or before Pater. And PAPIs, in fact, only guarantee obstacle clearance to 4 miles, and sometimes even less than that. If it's less than that, it would say so in the chart supplement. And so that's a very good reason to go look at the chart supplement on a flight like this. If we really wanted to descend below that minimum altitude, we could obviously switch to a visual approach, or we could cancel IFR if the weather allowed it. But of course, it doesn't make the terrain go away, so proceed with caution. The plan we'll file then is the Hawk 3 departure IK transition, San Marcos VOR at 8,000 feet. We have our standard weather briefing, and it's a great day for some IFR practice. The plane's on the west ramp at Long Beach where we left it from the last flight, so let's jump in and get going.